This is the question once asked by Pradul. So what are the values given in this question? It is given that is the magnetic field region lies between y equal to 0 and y equal to t. Contains magnetic field B equal to Bz cap. A particle of mass m and a charge q enters a region with a velocity v equal to vi cap. We have a three-dimensional Cartesian system x, y, and z. Okay. Now the particle is enters with a velocity v equal to vi cap. Sorry, first magnetic field is equal to B equal to Bz cap. This means it is we know that as per this coordinate system I have drawn, z direction is out of the plane, so magnetic field is also out of the plane, and it is lies only in the region y equal to 0 and y equal to t. So we are assuming that is this is the y equal to d, and this is 0, y equal to 0, because the center is 0, 0. Now magnetic field is out of the plane. Since in this question it is not clearly mentioned y equal to d means whether it is on positive axis or negative axis, we can also take it on a negative axis, y axis. Otherwise, we won't be able to solve this problem as per this given condition. So magnetic field will be lies. Magnetic field lies here, and this is the point D. Now the charged particle enters with a velocity v equal to vi cap. That means the charged particle enters along the x-axis. So it is only given I cap. So once it is enters the x-axis, apply the Fleming's left-hand rule. The velocity is rightward, magnetic field is inward. If you apply the Fleming's left-hand rule, you will be getting the direction of force is downward. But it won't be able to complete the path because once it is reaches here, it will exit from the magnetic field. We are asked to calculate the acceleration of the particle at the point of emergence or exit from the field. Actually, the path, the circular path, supposed to take this is, and this will be the center of that circular path, and that entire length will be radius. The entire length will be radius, but it won't be able to complete the circular path. It will come out, and at this point, the velocity of direction will be tangential to that particular point. Now, what will be this distance d we need to calculate in terms of r. So d is equal to, given already, d is equal to mv by qb. Sorry, mv by 2 qb. In the question it is given mv by 2 qb. So we already know that is mv by qb is the expression for mv by qb is the expression for r. So d is equal to r by 2. So this distance is going to be r by 2. This distance is r by 2. Now this is the radius. This is also radius. This is also radius because it's a circular path, and this is the angle theta which is turned. So we need to find out this theta first. Okay. Next target is to find the theta. So to find the theta, and here what about this distance? This distance is nothing but r cos theta. This is the adjacent side, so that can be taken as r cos theta. I'll just there is no space there, so this distance is nothing but r cos theta. So if this is r cos theta, then we will be getting a relation that is the total distance r is equal to r by 2 plus r cos theta. Because this is how r cos theta is by considering this is a right angle triangle. This is a right, as a considering this as a right angle triangle, we got it as r cos theta. So we will get that is r cos theta plus r by 2. R by 2 is the d, which is equal to total r. So everywhere r is there, so can cancel that one. So we'll get to cos theta plus 1 by 2 is equal to 1. Now cos theta is equal to 1 by 2, take it to right side. So cos theta is equal to 1 minus 1 by 2, which is equal to 1 by 2. If cos theta is equal to 1 by 2, definitely theta, that implies theta is equal to cos inverse of 1 by 2. Cos inverse of 1 by 2, we know that is 60 degree. So we got the value of theta is 60 degree. Now, if this is theta, that is 60 degree. If you extend this is, you will be getting here, this is also will be theta. Because at initial point, this was r and this was v. They were perpendicular to each other. Now, when r is rotated by a theta degree, this velocity also will be like this. Because that is always going to be keep 90 degrees. So this angle is also going to be theta. That is also will be velocity vector also will be rotated by theta. Okay. So that's the way we got it as there is theta is equal to 60 degree. But instead of plus 60, that will be downside, all right? It is below x-axis. So that is going to be minus 60. So we can say that the angle of v vector at emerging point is minus 60 degree. Now we have to find out this expression for velocity. Then only we will get the expression for acceleration. So then next step we have to do, that is to find out the expression for velocity, to find expression for v. So to find expression for v, so what is, if you have v vector is along this way, so this will be, this is the theta. Now this will be vx and this will be vy vector, vy component. So how will you write in vector form? V vector is equal to vx I cap plus vy j cap. That is v vector is equal to, that is vx is equal to v cos theta, adjacent side of it. So v cos minus 60. Minus 60 is very important because theta is downside. I cap plus vy component is v sin minus 60 j cap. That is v vector is equal to, what is v cos, the cos minus 60? Cos 60 is 1 by root 2. Sorry, cos 60 is 1 by 2 minus cos theta also, cos minus theta also cos theta only. So v into 1 by 2 I cap plus then v into sin minus 60 is minus of sin 60. Sin 60 value is root 3 by 2. So minus root 3 by 2 j cap. So we get v vector is equal to, v vector is equal to, let's take v outside. So we can take 1 by 2 I cap minus root 3 by 2 j cap. We got the value of expression for v. Now let's find out the acceleration. That's the third step, that is we can, because we got the expression for velocity now. Now the third step we can do to find the acceleration. So to find the acceleration, we can use the equation, that is ma is equal to q into v cross b. Listen very carefully. Here the acceleration is not linear acceleration, only centripetal acceleration. So a is equal to q into v cross b divided by m. Now first let's find out the v cross b parallel. So v cross b is equal to, v cross b is equal to, what is v? V take it outside, 1 by 2 I minus 3 by 2 k, sorry 3 by 2 j cross bz cap. Space for here, bz cap. So vb is constants outside, take it outside, vb into, first one is j cross z. J cross z will be my, sorry, this is I cap, okay. I cross z will be minus j. So 1 by 2 into minus j cap minus 3 by 2 root 3 by 2 into j cross z is I cap only. You already know how to find out the vector product, so I'm not getting to that one. vb, both are minus, so take minus outside. So you'll be getting 1 by 2 j minus root, minus is taken, so it will be plus root 3 by 2 I cap. So we got the value of v cross b. Substituting this is in this above equation here, so we'll be getting acceleration is equal to q into, what is v cross b? Minus vb into 1 by 2 j plus root 3 by 2 I divided by m. So finally we will have, minus is take it outside, so what will get a minus qvb by m into, I can write first I cap vector, so that will be better. So root 3 by 2 I vector plus 1 by 2 j vector. So this is nothing but option B. I hope you understood. If you have any queries, you can ask.